Okay, so today I'm going to tell you about the practical neural networks. So basically, what neural network is like, it is properly based on our nervous systems. So the definition, it's pretty much related to AI, and the definition of AI, I think most of you will be knowing it. So it is like uh, the father of artificial intelligence. Okay, so John McCarthy, like AI it is the science and engineering of making intelligent machines, especially the intelligent computer programs. So AI accomplished by studying how human brain thinks and how learns, decide, and work while trying to solve a problem, and then using these outcomes of this study as a basis of development of intelligent softwares and systems. So in practical life, I think most of you are aware, like AI is everywhere. ML is the basics of it, then it comes for deep learning, and then it comes for AI. And ANN is also a part of it. So on a practical viewpoint, ANN, that is artificial neural network, uh, it is just a parallel computational system consisting of many simple processing elements connecting in a specific way in order to perform a particular task. So, like, it is mostly uh, task based. Like, you can recognize some of the pictures, you can create the images. If some default is there, it can also correct. Like, some algorithms are there, lock and key algorithm. Like, if you have some locks and keys, and you have something like you have broken key and it is not accepting, so it's like it can make itself, like, it has the weights and it will make the key again and you can use it properly. So I will teach you it in deep after some time. Okay, so learning in neural networks, the basic learnings are of three types: supervised learning, reinforcement learning, and unsupervised learning. Our brain is unsupervised learning. It trains and then we will use that same data in different fields and work for it. So, like, supervised learning, that is, it is a learning type. Like, it is like you have trained a particular format of data in a specific way and then you are using it for a particular task. So, it is basically task oriented learning. Reinforcement learning, it is learning with limited feedbacks. Like, you don't have much knowledge and you have just the basics and you are doing it. And unsupervised learning is learning without any help. Like, I think you all can understand learning with mm, not learning with teachers and learning through the books. It's like that only. Books is also not that, but yeah, a type of it is books. So, supervised learning. In supervised learning, the training data is input to the network, and the desired output is known. Weights and bias are adjusted until the output yields the desired value. I'll be teaching you the weights and the biases when I'll start the neuron model. That would be easy for me to tell, and easy for you to grasp. So, unsupervised learning, input data is used to train the network whose output is known. The network classifies the input data and adjusts the weights by feature extraction in input data. So, reinforcement learning, uh, here the value of the output is known, but the network provides the feedback whether the output is right or wrong. It's just the semi-supervised learning. Like, properly like it's not properly supervised, and in between of supervised and unsupervised, it is there. So why to learn, like, why to study for artificial neural networks? Let us say, I think I got some message. Got it. Fine. I'll continue. So, why to study artificial neural networks? These are extremely powerful computing devices. Like mostly you can understand, like uh, it can recognize, it can recreate, it can do many of the things like image processing, recognizing with some particular features, extraction of particular features, and all. So it is like that. And massive parallelism makes it very efficient. Massive parallelism means if some part of na, like if we are having a circuit, and if we have a parallel circuit with it, and if some short circuit some problem is there with some of the line, then we can use the alternative path for it. So that increases its efficiency. Like if some part is damaged, it can be used for other it can use other path, and the device won't fail to pass through. They can learn and generalize from training the data, so there is no need for enormous deeds of the programming. So like it's just the basic programming. I don't think that would be much required. Guys, if you all are having doubts, then please speak up, because that would take time if I go and take each and every doubts in the chat section. So please speak up if you have doubts. They are particularly fault tolerant. As I said, they are fault tolerant. Like if you are losing some of the data and all, it can regenerate it. It does not get much effective if some part of program has failed, because it has multiple other parts. It would affect a bit of the efficiency, but that will work out. So like you won't be suffering much for that if some of the part of the program has failed. There are very noise tolerant, so that they can cope up with the situations where normal symbolic systems would have difficulty. Yeah, so they are very much noise tolerant. Like some of the digital systems are not noise tolerant. They need the filters, and that would be there. So I think that's better. Like it is very noise tolerant. Like it has inbuilt things, inbuilt functions, inbuilt filters, and also it doesn't require any much of the things. And the things which it can require, it can sometimes regenerate. So in principle, they can do anything a symbolic logic system can do, or more. In practice of getting them to do it is rather difficult. So the uses of neural network, ANN, like artificial neural network, brain modeling. Model of the human development helps the child with the developmental problems. Simulations of adult performance under uh, aid our understanding of how the brain works. Neuropsychological model suggests remedial actions for the brains and the damaged patients. So like as I said, it can recreate, it can think, like just like a normal nervous system of a brain. It works in the same way. So it can model a brain, but it is not actually the brain, but it is the artificial brain. And I think most of the AI, like in Google, as you all know, the reputed, very much reputed company, and you are all using Google nowadays. So it is having a special department for it, research department for neural networks. So you can all can think like how much important it would be, like a special department for this. So that would be, I think, real world applications. Financial modeling, like predicting the stock, shares, currency, exchange rates. It can predict all the things, just like in the first of our session, machine learning model. You all have seen like how can we predict the things and all. So it can predict. It has different algorithm. It is not necessary we use regression model. It has different models like backpropagation and all. So it can uh, predict the things with the data sets which we are providing. Computer games, intelligent agents, backgammon, first person shooters, all are this type. Pattern recognition, this is very much important, like speech recognition and handwriting recognition and solar signals. As you all know, like fingerprint recognition. As sometimes you are having fingerprint sensor in your phones. I think most of the people are having. It is basically the algorithm. Like sometimes your phone does not, you don't just touch it completely, but it recognizes your fingerprint. That's just based on these things. Like sometimes you have cut in your fingers and still the phone recognizes your fingerprint. All these are this type of things. So it can recognize the pattern, it can create the pattern. So okay, data analysis, data compression, data mining, noise reduction, function approximation, ECG noise reduction, bioinformatics, uh, protein secondary structures, DNA sequencing and all. So yeah, I think so. This is what a basic neuron is looking like. This is soma, this is dendrite, axon is this much, whole part is known as axon, and this is synapse. So dendrites accept all the inputs. Like if something is there, we can feel the touch of our hand. If someone touches, if we touch something and all. So it can accept all the inputs. It can accept inputs from different neurons also. Like you all know, neurons are very much interconnected to each other. And soma, the processor, the processed in sorry, the process input. Like this part, this whole part is the soma, and axon. The turns the it turns the processed inputs to the outputs. Like the main functioning, the main thing is in this one axon. Like how it is developed. This is the main thing which it is there. Synapse, the electrochemical contact between the neurons. This is like this contact point. This you can see like in the picture. It is clearly mentioned what exactly this is. So exchange of the information is taking through these things only, and these are connected to again some dendrites. The information travels, and then this thing continues. Uh, Guys, are you having any doubts till now? Please respond.
It's fine.
It's fine. Okay, fine. Cool. So, shall I continue? Okay, fine. The artificial neural model, the inputs, as you can see in this picture, the inputs are x1, x2, xij. These are the inputs. Then the weights are the things like I'm explaining this. Like weights are the things like if sometimes you touch something, sometimes you feel it quickly, sometimes you don't feel it quickly. So it's like some part of like yeah, uh, you can take an example of a runner. A runner has muscles developed in the legs. So why is it so? Like it is developed due to exhaustive usage of that thing. Weights are the things which are that way only. Like it develops so much of potential. Like it's just like a potential. Like you have a more potential at a point, then it comes like if you use some part more, it is like the weight is more. If you use some part less, it is the weight, it is having the weights are less, because sometimes some things are more important. Yeah. Mm, Someone's mic is on. Any doubts, guys? Any doubts? I think someone's microphone was on. Fine, no problem. So the weights are like it depends on how much you use some information at a particular. It is decided in that way only. Like it's just like a probability. Sometimes when the sample outcomes are more, the probability is more. The sample outcomes are less, the probability is less. So it is that way only. Just the thing is, it's not between 0 and 1. Like it's not just between 0 and 1. It can have different values. So yeah, the inputs of the network are represented by x1, like you can see here. The mathematical symbols are x and this one. Okay, so each of these inputs are multiplied by a connection of the weights. These are the weights. So like some inputs are there, some inputs are coming, how much they have a particular weightage. So that weightage would be counting it there. Then after that you have a transfer function. So that transfer function is the summing part where you sum up the all the datas. Okay, that is this one, w1 into x1 plus wn in dot dot dot, like w1 into xn. These products are simply summed up and fed it to the transfer function fs. Transfer function, I think, yeah, you all will be knowing about it, or if you don't know, you will be knowing in the classes, to generate a result and then the output. This is the transfer function. Here we have a particular threshold value. Like the threshold is uh, like sometimes your neurons always get some information, but it does not transmit the information to other neuron until its activation function is activated, like it has crossed the threshold value. If it has crossed the threshold value, then only the activation function gets activation fires up. So then only you will get some information. Okay, so this is the model of the neuron. Okay, so the similarities, as you can see, the similarities, like this is actual neuron and this is artificial, and this is the similarity. Dendrites, these are input units. So synapse, which are the connection of weights, and then we are summing it up as a function, that is the transfer function, that is, I think, the transfer function. Yeah, and then the computation of it, like the activation function. If it activates, it fires. If it doesn't, it doesn't. So axon is the output unit. Okay, so the difference, like guys, any doubts till now? Because this is very much important, so I would like to ask, like, if you have any doubts, guys, respond.
No doubts.
No doubts? Okay, fine. Okay. So, yeah. Digital computer. The difference is there between, as I said, right? The difference is there between the neural networks and digital computers. Deductive reasoning, we apply known rules to input data to produce the output. Okay. In this, the inductive reasoning is there. Given input and the output data. Okay. Like we construct the rules on our own. It is not like what the basic algorithm is. It is not like that. We have to construct its own rules. Like we are the master of the rules. We don't have to follow any rules. So computation is centralized, synchronous, and serial. But here the neural networks, here the computation is collective, asynchronous, and parallel. That is why it is much effective. Like all you can see, like it is just centralized, like it has only one part to go from one point to the other. But due to this, like, what's the point of, yeah, this point is very much centralized data. This data is only having one path, but here we have a parallel path. Like if something happens to a centralized path, the data can't transfer. Here, it is not the problem. Here, the data is traveling through another part. Okay, so memory is packeted, literally stored, and location addressable. So, memory is distributed, internalized storage system, and all. It is basically non-fault tolerant. The one transistor goes and it no longer works. As I explained, this is the most, like, this is the problem with it. Like digital computers, if something goes on, like it just breaks down. But here it is not the system. Fault tolerant, redundancy, sharing of the responsibilities. Like this is the thing, right? If you have the responsibilities on only one person and that person breaks down, like he has some problem with it, then the problem will be there, like the working won't be done. So that's the thing. Here the responsibilities are shared, the weights are shared. So it's not about just the one thing, it's about many other things. It is exact, but it is inexact. It is not much appropriate, but it is good. It is having a accuracy. It's not accuracy. It's having a definite value. It is not having a definite, exact definite value. So yeah, the fun fact will be there. Uh, our brain constantly predicts what other people are about to say before they say it. Think about it, like if someone has done some DA, like that would be a better example. Someone has done some DA and you are using the neural network and you are getting just one or two questions, and then you are using that same weight vector, and then you are using it. So you can see, like uh, you can use it, like you will be getting the whole DA of him. Like sometimes some people give one or two questions, as you all are familiar with it. Then you can use the whole uh, neural network, like whole DA of it, from just one question. So it is like that, but it should be something related to the thing which is feed it to it. That's the thing. If it doesn't have the things which are matching to it, it won't work. Okay. The Maculopath model. The first artificial neuron was there. Maculopath was the first person in 1943. Yeah. 1943, he has made the first neural model. But here the problem was that the weights are always fixed out. So like here we can't change the weight. So he has observed a single neuron. He didn't knew much at 1943. That much time we didn't have this much of knowledge, but he was the first person to think about it. Uh, Produce the first neural model, which was based on their artificial neurons. Although this work was developed in early 40s, many of the principles can still be seen in the neural networks of today. We can make the following statements about Maculopath network. The activation is binary. Yeah, 0 and 1 is there only. It doesn't take other than 0 and 1. So that's the problem with it. Like it has yes or no. It doesn't have anything in between. So that's the problem. That is, the neuron either fires activation function or does not fire. That's what I said. For the new network shown in figure, the activation function for the unit y is fy dot in. Like you can see here, this is f. So here the activation function would be there, and uh, if it is greater than some of the threshold value, then only it will fire. So this is the activation functions. As you can see, this part. I think I should use the pen. Yeah. This is the main thing which I am telling. The activation thing. I would be telling it in deeper, how much activation functions, how they work. But this is what the main thing is, how it fires. Else zero. Okay. So neurons in Maculopaths network are connected by direct weight paths of if the weight on a path is positive, the path is excitatory, otherwise it is inhibitory. All excitatory connections into a particular neurons have the same weights, although different weight connections can be put to different neurons. Here it is having same weights, as it is not mentioned, we take it as the same, but we can have it like here we can have two, here we can have two, here we can have one, here we can have three, something like that. That can be there. Okay, so just don't think like we have the same weights, equal importance, equal things. That's not there. It's just like a probability. More weights can be there, more weights can be there, more weights can be there. So that's the thing. Each neuron has a fixed threshold. If net input into the neuron is greater than the threshold, then only it fires. Okay, fine. I have to, mm, it takes one time step for a signal to pass over one connection to the another, so it's not important. Yeah, biasing. This is the important thing. You will be getting it in each and every model. Every point of time, it will be there. Biasing. Bias allows you to shift the activation function by adding a constant, that is the given bias, to the input. Bias in neural networks can be thought of as analogous to the role constant in the linear function, whereby the line is effectively transposed by a constant value. So, like, I can say, yeah, this is the thing. So, here we are giving some bias. This is bias B. Some B value is there, and it has definite weight bias. WB is there. WB and B, I think we are using the same thing, so I won't be needing it. I need to change it. Yeah, this is one of the main thing. You all are needing to be understanding this one, guys. Any doubt till now, guys? Any doubts, guys? Please respond. Am I audible?
No doubt, Bhaiya.
Oh, okay, fine. Okay, so this is what the main thing is. The activation function. These whole are the list of activation functions. Like we can use any one of it. We can design any of it. If we want any other function, then it is also there. You can design it, use it as much as you want. Identity, as you can see, y equals to x. That's the simple linear equation. That's the activation function. F dash is one. That's, I don't think so. That would be a thing to explain. Binary step functions. I think the first years maybe not knowing about it, but yeah. Uh, Unit step functions is other name of it. Like you can see, it is zero till some threshold. This threshold is fixed out to zero. Here I told you, like the threshold is t, some t value. So if it is not equals to zero, it could be some other value as t also. So then the this value, y value, also will change. So it will, like, it will go this way. You can see here. Sorry, it will be the straight line. Yeah. So some t value, at some t value, it will be activating only at a some particular value. It can be 1, 2, 3, anyone, any value, any integer, any float value, anything, but you have to define it in the code if you are using the float value. So logistics, soft step function, like I think so this is same as same, or I think if you have the subject like Harsh told us, Harsh, you would be having it, Harsh, yeah. So yeah, the thing is, as you can see, this one, this is the most important functions among all. Like in back propagation we use it much of the times. Like it's just the usage, and just you remember this formula also, because in sometimes we use f dash for activation functions and binary for going back also. So fx, this is 1 upon 1 plus e to the power minus x. That's the main function, and this is also known as sigmoid function. Write it, sigmoid. this is sigmoid function. So this is tan h. You can use it. It is also similar to sigmoid function, but the accuracy percentage of each epoch, like the whole cycle, is much in tan h. Arctan is tan inverse rectified. Yeah, ReLU. This function I'll be showing you, I think, in the code which I have in my project. So that's the basic thing. And yeah, this is the activation function pre-ReLU. Pre-ReLU is a function same as ReLU. ReLU is like real linear functions, like it's that. So this is the main thing. ReLU function, it activates only at a particular threshold and it follows the same path as x value. It can have different threshold values also. So it can be t. Some t value could be there. It can be shifted function and all. And this is the problem with it. Like some error is there. So we use rectified linear unit. Okay, fine. So rectified linear unit, this is not used as common, but if we are using the digital data, then ReLU function is fine. But if we are using analog data, some errors are there, so sometimes we use this one. So and then it comes the exponential linear unit, ELU. That's not much, that's not of much requirement, I think. It won't be much there. Soft plus, this is a bit interesting one. You will be using it. Soft plus, soft max, these two are functions which are used in like much much tougher codings and all. So this function you have to remember. This function you have to remember. I won't mark it. Yeah, learning rules. These it is having different learning rules. Like uh, like what I think is just like CBSE, ICSE, all that things are there. That's the same way here the rules are working. We have to go for some project or something. We have to use a particular learning rule. We can't switch the rule in between. So that's the thing. Different learning rules in neural network. Hebbian rule. This is important rule. This one and delta learning. These two are much important than any other. Like for basic projects, I think these two rules would be working out. It identifies how to modify the weights of the nodes of a network. Perceptron rule is like network starts its own by assigning a certain random value to its weight. It would change the weight. Here, the changing of the weights is there, mm, and it would be something different. But here, the some random values assigned at first. Here, you will find out the value. So that's the thing. Here the values are assigned and then you go for it. And here the values are there. Like you will have to find it. That's the thing. This is most important. Delta learning rule. Modification is modification in sympatric weights of a node is equal to the multiplication of the error and the input. So like it's something like error value, something, some error value is there, er minus x, the whole thing is there. This is what it meant. Sometimes the square root rule and all, everything will be there. Rms errors and different types of errors are there, so we will be using it. Sometimes it becomes square, sometimes it becomes just the same thing. So that's the thing I would be telling you in like questions if possible. Correlation learning rule. The correlation learning rule is supervised learning. Outstar learning rule we don't use it normally. It's for like complicated projects. You don't use it normally. So I won't like to teach it. Yeah, have postulate. This is one of the main things. As I explained earlier, axon of cell A is near enough to excite a cell B and repeatedly and persistently takes part in firing it. Some growth process or metabolic changes takes place in one or both the cells such that A's efficiency as one of the cells firing B is increased. That's what I was saying. Like if he is giving something, like just think about some two friends. Yeah. So yeah, just one second. Yeah, if two friends are there, they are sharing things with each other. They are sharing very much each other. The bond between the two friends is much more than the ones who are sometimes sharing, sometimes asking, sometimes talking. Just like the friends, two friends. Like you can. This is the basic example which I can give you. Just between the two, someone is giving something to him and someone is returning or something like that. The relation between or the bond between the two increases. Bond strength will be increased. So that's what Hebb postulate is. So yeah, the popular ANN architecture samples. This is Perceptron, two inputs directly output. No hidden layers will be there. So directly this is the weights are defined, W1, W2, everything will be defined and it will directly give out the outputs. Multi-layer perceptron. Multi-layer perceptron has the uh, hidden layers. These are the hidden layers, the green ones, which you can see. These one are hidden layers. These are hidden layers. These are input layers. These are output layers. Output can be much, as you can see. It is not fixed up like three inputs. If you are having more inputs, you need more layers. Some hidden layers can also be more. That is why it is multi-layer. Okay. Then recurrent neural network. Here, in this recurrent neural network, the data is logged out. Like the data in it, I will be explaining you. But here in this one is blue, so the data is logged out. Like you can't uh, like yeah, this is very much used for lock and key. That's what I was saying. Recurrent neural network. Sometimes the data is there. So that's the thing. The data is logged out. You can't change it. You can use this one only for pattern. Like I think for lock and key method, yeah. In lock and key method, as you can see, if the data is feeded out, like how the key would be, then it would make the key in the same order. Or if you would change it, then you can think of like you won't be able to think like how the key was. It can have some different outputs also. So that's why it is logged out. The data sets are logged out in this one. LSTM, same thing in this also. Just the thing is here you can use it one time and then change the data whole sum and then use it for other. But here you have to change the whole model. Hopfield network. This is one of the best network. Here, every single input unit is connected to every single other unit. As you can see, every single unit is connected to every other unit. This is the basic property of it. Like this is one of the best property which will help you Hopfield network. But it is a bit difficult to understand. Here the weights are something different. It's not the same algorithm which I told you like last time. Deep learning. Here the many hidden layers are there. Many. Like here we can see only four. And every hidden layer is connected to every input layer. This is connected to every layer. This one, single one, is connected to every other of these one. This is what the thing is. This is what complexity means. Everything is related to every other thing. So that's what deep learning is. Machine learning is a part of it. So deep convolution neural network. I don't think so. You would be using it. Yeah. But I will be telling you. Input units. Kernels would be there for it. Convolution pools. These pools are there. I don't think this would be much required. That's why I won't be teaching you, and you all will be confused very much with each and every one. Yeah, this is the thing. single layer perceptron. As I explained, neural network having two inputs in it and one input in, no hidden layer is there. In this, it is like a single, unlike the single layer, but it has one hidden layer of neurons. It can just have, मतलब like, yeah, more than one it can have. So in this, yeah, this is Hopfield network. This is one of the important thing. A fully interconnected network of neuron in which each neuron is uh, connected to every other neuron. The neuron is trained with input patterns by setting a particular value to the neurons to the desired pattern, right? So everything is like it is trained in that way only. It is having a desired pattern. Then its weights are computed after that. The weights are not changed once trained for one or more patterns. The network will converge to the learned patterns. Deep learning neural network. It is a feed-forward neural networks with a big picture which I explained earlier. It is having uh, every single layer is connected. Like you can see here, what I told. Yeah, this is the thing. Input is connected to every other hidden layer, and then this hidden layer, this part is connected to every other single hidden layer of the next level. That's the way how it works. It is very much complex, so everything has to be interconnected. Yeah, then it comes the recurrent neural networks, type of neural networks in which the hidden layer neurons has self connections. Recurrent neural network possesses memory. That's what I said. It has the memory locked. Yeah, this hidden layer is locked out. At any instant, the hidden layer receives the activation function from the lower layer as well as its previous activation value also. That's what the thing is. LSTM, type of neural networks in which memory cell is incorporated inside the hidden layers neurons is called the LSTM network. Convolution neural network. I haven't shown the picture here. Convolution network is there. I would be explaining it at last. It's not deep. It's something different. Yeah, I will be explaining it at the last. Convolution neural networks. It is a class of deep feed-forward artificial neural network that has successfully been applied to analyze the visual imagery. Like you can extract some feature. That's what I said, right? The extraction of the feature from some layer and something that's this thing. Convolution neural network. You will be doing the project for it also, I think, if you have that subject. Rosenblatt, a psychologist proposed the Perceptron model. As I explained, it uses the Hebbian model. It has the it has weights on the connections. Learning took place by adapting the weights of the networks. The weights are adaptive. It can vary with each other because due to the uh, input and output. Like what is the desired output and what is the given input. It varies in the that order. Mm, was refined in 1960. I don't think that's important. Uses an iterative weight adjustment that is more powerful than like this is the perceptron. Yeah, this is what it is. Perceptron learning rule. This is what the thing is. Habian, I had explained you like the friends with the friends example. I have explained you. That's what Hebbian model is, but the perceptron is a bit different. It uses iterative weights adjustment that is more powerful than Hebbian rule. Perceptron uses threshold output functions and Maculopaths model of a neuron. Their iterative learning converges to a correct weights for a given training sample. As the like some sample would be there. This is what the thing is, and the change in the weights only if computed what is different from the target output. I don't think this is required. Yeah, but it is the same way as I explained. This is what the thing is. Hidden layers are there. The data, something operational data or something is stored in this. You give input here, some input, it processes the data and then it gives out the output. But the data is fed here only. This is predefined. This whole function is predefined. So that's what the thing which it wants to explain here. This is what the multi-layer perceptron is there. Two hidden layer is there. You can see here all the processing data which you want to store, that is in this one. All three layers are having some particular data, and the activation functions also are there in the single hidden layer. And then if the activation value crosses, it would gives the value to the next layer, then to the next layer, then only it gives the output. Otherwise it won't. If one of the layer fails, it won't give the output to that layer. Backpropagation. What's the time? 11:58. Yeah, I won't take much time because I explained the coding part also. Backpropagation. Backpropagation. Yeah. In this backpropagation, as you can see, these are the input layers. These are input layers giving all the inputs to from the users or some person, some particular training data. So this is the sorry, yeah, this is what input is. Then after that we have the hidden layers. Different hidden layers we are having. It's just showing the single hidden layer. We are having different hidden layers, and then after that each of the input layer is connected to every other hidden layer, like every other element of the hidden layer. So it is connected like that, and then after that it sends to sends the data to this one, output layer. Then output layer is there. Then output layer, if the data fails out, if the activation function or some problem is there, it does not recognizes something, like if it does not recognizes, let's say it does not recognizes your face which you feed it, so it would directly go back the error signal. The error signal, it will directly go back to the input layer. Again the function starts, and in this way it goes on. Like every time the weights are changing, every time the it is really very complex. Like if you think like I would be I was about to share some examples for it, but it's really very tough to understand. That's why I just explained the algorithm basic what it is like. So the error signals are transferred backwards, and then again the operation starts, again goes here, and yeah. With this you can compare the outputs also. Like it's not a single way path. You can go with outputs also. If you have some output, you can go for the input. That's what the thing is. It's not a single way path. It has input signals. Input signals are about second thing, like it propagates. So that's what the thing is. Yeah, convolution neural networks. I think I should ask.
Bhaiya,
Huh.
uh, like in the previous model, does
Hmm.
it maintain the error which is from the threshold value, or it tries to reduce it?
At like see what the thing is, like we get the input, it's the hidden layer, it goes to the output. After that the processed output is there, some learning values are there, like some point 2, point 4, something, some learning values are there. So it propagates to the output layer, but if it does not recognizes it, it propagates back. Like so you can see like what I told, right? Error functions, this is what error functions is equals to. Here in backpropagation only it is error value means the y value which was accepted minus the input value. So that's what the error value will be, and then we will subtract the x value and then square it. This is what the error value here is. So it won't be the same. As you can see, it would go back, again comes forward. So square value, like if the value of error is less, so it would go down and that way. Like it won't increase because error value, as you can see, error value would be basically most like we stop at 2 point something value, 2 point values 2.02 or something, some values are there. We would stop at that point only. But the thing is, the error is reducing continuously, and then after that it becomes a bit constant, like in seventh digit or 12th digit. If the difference is there, we won't mind it. So that's the thing is.
Yeah, if I may, as you asked about the error, see the difference between a failure perceptron and a backpropagation model is just the difference of a feedback network. A feedback network means the output which we get after modifying it a bit, we give it to the input and it gets processed again. So if in a failure perceptron, we take the output and by applying some formula, we give back in the network, so it optimizes the error. Here we use mean square error because suppose our error is 6. So using mean square error, the value which we'll get is the magnified value of error. It means how much deviation which we get from input would be magnified. So we again pass it to the neural network. Because of multiple layers, the error would get reduced. This, if you want to visualize it, just like active noise cancellation. As you must know, in active noise cancellation, we produce a anti-noise wave to cancel out the noise. Just like that here also, when we give our feedback error to the neural network model, it produces a anti-node in order to that error. The new weights and biases are then created, and then new error is calculated, and then just it is repeated again. And we also specify an optimized value of error. Until that value is reached, the this process carries on, and if that value is reached, it means the desired accuracy is achieved. At that point, it would save the weights and biases for further classification. Yeah, I hope that it would be clear now.
Yeah, thank you.
Yeah. If
Yeah, no
you
problem.
want, I think I should share some examples if you want. Do you
Yeah,
want?
yeah, yes.
It's not the coding, it's just the example. So
Yeah, just the example. Yeah.
this is what it basically looks like. This is using a binary sigmoid activation function. You can see it, right?
Yes, yeah.
Yeah, you can see it. This is what input layer is. Weights are predefined random values at first, at very first, like, and then what I said is this learning rule. As you can see, learning rate is 0.25, right? So everywhere we need the learning rule, because if we change the weights, we need the learning rule. Okay. So binary sigmoid function, and this is the second layer. This is what it is like. Initial values are there. So, mm, yeah, this is what it is like. V not one, V11, Vij values are there. So Vij is there. So every layer is connected to every other layer. So I would tell you with an example, it is easy for me also to explain. Yeah. So the weights are defined as I told you. So the weights are defined. V values, like the values, these weights are also defined out. So it is there. We are using these are the weights, like what we can say, these are the predefined weights which I told you, right? So this is the thing, the function is there. So z I n j is equals to v naught 1 plus summation of xi into vij, right? So all these are there, like just what I can say, v naught 1 is zero point 0.4 is this one, biasing values. So in this way, I don't think like Shaurya was there, right? Yeah.
Yeah.
I think should I explain everything or just the back propagation error point, how it
Okay.
is?
So just one thing that if error is keep on reducing, but it will always be greater than threshold, right?
Not exactly the threshold, but the thing is like, wait, I will let you know.
No, for example, our we have set up some threshold value for
Yeah.
which have a digital high, and below that we have a digital low.
Yeah,
So error is relative to that threshold value.
error is not related to that threshold value. What I said, like, can you
Sorry,
please?
sir. What error is actually is,
Yeah,
by training, we give a desired input and a desired output. So the error would be calculated as what output we get from the network minus subtract it from the desired input which we gave. So that would be the error. So that error is always less than activation because that error is calculated in fractions. See,
Oh,
so error always be low. And if you are asking about the threshold, so instead of threshold, the value is not always one. It can differ according to a model. So the value of threshold is set according to that. The error can at max be 100%, which is obviously not true. It would initially would be around at max to max it would be around 95%. At least some accuracy you will get initially. So the activation function will always be high in that case. While reducing the error, it would get reduced. If you are getting confused with the activation function, you can see it like it is like a water tank, and a water tank has a level after which water would stop coming in it. Now the error in it would be the initial volume which we assumed change because of the design of a water tank. As you have seen, the water tank is not a cylindrical, but when we calculate the volume, we take it as cylindrical. So that difference would be an error. And the threshold function, the activation function which we set, is the amount at which the water will stop. So the error would always be lower than that. All the programmers keep that in mind.
yeah, understood. Thank you.
yeah, sure. I think the doubt would be clear with the
Yeah,
step 5. You can
yeah,
see,
yeah, I saw it.
yeah, that's what I was telling. Like, it's not dependent on the threshold. It's the target which is it is dependent on.
Yeah,
So
okay.
it should reduce. Yeah. So the doubt is clear. Will I
Yeah,
proceed?
so much.
Okay. Yeah. The CNN. This is like one of the typical models. CNN, it has two main processes, convolution and sampling. You can see like the input which you are giving. The input, the function, the biasing, like the transfer function is created and then it makes the whole lot of matrix. This is the matrix which you can see. And then we choose a particular random values. We put out the function and then the values would be there. Weights are, I think the weights are changing, so the weights are always there. Biasing is also changing, and then we will use that activation function and then create some output related to it, right? Sorry, yeah, then we create the output for it. This is what it is basically like. It's the stored matrix what it is like. Convolution, as you all can, I think, I don't know, maybe you will be knowing, convolution like convolving two or more things. So that's what the thing is. We are convolving it. We are making some, like, it's basically image processing, speech recognition, and it has the unique advantages in speech recognition and image processing. This is what the main thing is about it. So, mm, enable effects, yeah, deconvolution. Sanskar, would you like to explain it much? Like, he has worked on this on some projects on it, so better, it would be
You
better.
continue it. I will explain it when I will show them the coding. I will explain that in that time
Okay,
only.
fine, fine, fine. Okay, so CNN, convolution neural network. It has basically the two processes, convolution and sampling. Convolution processes uses a trainable filter FX. The filter is there. So the filter is there. Deconvolution is deconvolution of the input image. The first stage is the input image, and the input of the after convolution is the feature image of each layer, namely feature map. Like, this is what the feature map is. This is what it is. Feature map it is. Like, see what I can tell. Like, if you are having some number 5, right? 5 is, it can be written like, write it. That would be better. 5. This is what 5 it is written like. here we can make a matrix of it. Yeah, 3 cross 3 matrix. Yeah, this can be there. 1 1 1 1 1 and 1. This is also equal to 5. All these values are 0. Say, right? Yeah, this is what it. Yeah, 5 can be written in this way also. So that is what it is written here. Feature of the each layer, namely the feature mapping. This is what feature mapping is. Like, yeah. Then add a bias bx. Then we are adding some bias values, like some points, some extra values. As I said, right? Biases are something related to the activation functions. Like we are adding some constant values as you can see. Yeah, yeah. Allows you to shift the activation function by adding some constant, right? So that's what it is, right? Yeah. So it is like that. Biasing BS, we can get the convolution layer CX. Then after that, after adding biasing to it, this is what BX is up. We will add some BX values, and then we will get this one, right? This is what it is written here. A sampling process, n pixel of the neighborhood through pooling steps uh, becomes a pixel, and then by scalar weighting wx plus 1. Wx plus 1 is like the weights are changing in that one. So that's what the thing is. Adding a bias bx plus 1, and then by an activation function produces a narrow n times feature map sx plus 1, right? So it would narrow down the feature extraction, and it would provide this thing, this sx point, which I am speaking about. The key technology of it, CNN, is the local receptive field sharing of the weights, subsampling by time or space so as to extract the feature and reduce the size of the training parameters. The advantages of CNN is that to avoid the explicit feature extraction and implicitly to learn from training data, like uh, it is having some features would be added to it. Some training data is set out, some features are added by bias, I think you can say. Some features are added, then we are classifying. Then after that, by one we will be classifying and using it in this way. Activation function is at class, right? Yeah. So CNN that avoid the explicit feature of feature extraction and implicitly to learn from the training data, and the same neuron weights of the surface of feature mapping. uh, Thus the network can learn parallelly, reduce the complexity of the network, adopting some sampling structure of the time or space, can achieve some degree of robustness, scale, deformation, displacement, input, and all. So with this, I think I'm done with it. Yeah, so these are the mainly three models which I have explained. We have many other models but I haven't explained you all due to lack of time, because there are many of the other things. You say like MaxNet, Adeline, Madeline, SOM, everything is there. So they are pretty much interesting, but the basics for them is also same for it. And these three models, I think these are the basics for most of the models which we will be using. So with this, I think Sanskar, you can take over. The coding will be taught by Sanskar. Sanskar, guys, am I audible?
Yes, Bhaiya.
Okay, fine. I think he's having some issues. No problem, I will explain you all. You need no, Sanskar, you're not audible. You are muted. No. Okay, fine. Till that time Sanskar comes, I will explain you all. Okay, fine, Sanskar. I will explain you all about one of the project and my being was based on weather prediction. It would take a bit time to load.
Am I audible now?
Huh, yeah, you're audible.
Yeah.
You can proceed, Sanskar.
Can you stop sharing your screen?
Yeah, fine.
Is my screen visible to you?
No. Yeah, it's visible right now.
Okay. So I hope all of you have downloaded the required libraries. Is there anyone who has not downloaded? All right. Uh, is there anyone who is using Jupyter Notebook for trying out these codes?
I am using.
Is there anyone who using normal PyCharm ID or a Spider or something like that? I'm asking because I will be telling the codes according to that only. Great. So everyone is using Jupyter Notebook. So let's proceed. This program is quite a short program, so I think you can write it while I am explaining. Share these programs in the chat box. I have posted the code in the chat box. You can take it from there. Yeah, if you're using Spider, I don't remember how to download the libraries in that. Since I have used that, so I hope you have downloaded the libraries. Many.
Yes, I have downloaded the libraries.
Yeah, good. So let's proceed. First of all, you have to import NumPy. Now, NumPy is a library of Python which helps us in handling the arrays, the matrices. For training a neural network, we always use a matrix, rather whether it be a 1D matrix, 2D matrix, or a 3D matrix. We use matrix because it's a very well-defined array of numbers. So if we use normal scores instead of a matrix, it gets a little messy while training it with weights and biases. So in order to handle those matrices efficiently, we use a library NumPy. We import NumPy as NP. Now you can NumPy as anything you want. I have it is as NP. So instead import it as something else. Let's say NP NPY. So wherever I write NP dot something, here is it in NP dot zeros. Suppose you have imported it as NPY. So instead of NP dot zeros, you will write NPY. Right. If you have just written as import NumPy, just write NumPy dot zeros. Right. Let's move now. We create a class Perceptron. So here we will be building a single layer perceptron, which my friend Purushottam has given to you all. Now for what is epochs? See, epochs is the number of repetition. It means how many times will this network run on itself again and again in order to optimize the weights and biases to give a better result. So here I have given epochs as 100. You can give as many. Now this is a single layer perceptron. Obvious that we cannot handle such big problems, but obviously for just learning purpose we can use. Practically not used. The most used neural network models are CNN, ANN, and RSS, RNN, and LSTM. These are used mostly in regular life. So here we will be building a person model and we will be training it on XNOR model. I hope you all know what XNOR is. Hello?
Yes, Bhaiya.
Yeah. So for XNOR, if we give the input as 0, 0, we get 1. If we get 0, 1, we get 0. If we get 1, 0, we get 0. If we get 1, 1, we get 1. So basically what XNOR is, if two quantities are equal, we will get a digital high. If two quantities are not similar, they are different, we will get a digital low, which is 0 or 1. So first of all, we make a class perceptron and then we will fit our input in it. First of all, see here we write a template for defining init. Init will be the driver function for perceptron. Have you all pasted the code in IDE? I have sent it in the chat box. Hello? Hello? Am I audible?
Yeah, you're audible.
Yeah. So you all have pasted code. Here we are just defining the driver function. This define init. Second, we are defining the activation function. Here we have used a step activation function with threshold value 0. It would return 1 if the value of x is greater than 0 or 0 value of x is less than 0. Then we define a predicate function in which it will give all the parameters for this. Then we fit this we fit our input in this perceptron model. So here, as you can see, I have used a for loop and dot epoch. It means the self means in this class itself, it is taking the value from this self. Here we have defined objects, so it would be taking all its pointing to this object. So on 9, I gave epochs as 100. So here self dot epochs means for dash in range 100, it would run till it is in the range of, it would start from 0, 1, 2, 3, 4, 5, 6 till 100. So 100 times it would run. Now for d dot shape, what d is, see here we are fitting self dot x dot d. So x would be the input which we give for training the and d would be the output which we need. So d dot shape means the size of d. Suppose we give d as a one-dimensional array with 8 inputs. So size of d would come as 1, 8, depending on one row and 8 columns. Like here, I gave d as one row and 4 columns. So the shape of d dot shape come as 1, 4. Now d dot shape dot 0. So shape dot 0. What this 0 means is the first element. It means the first row. What size of first row? Now here we are setting the model. We know that it would be a one-dimensional array. It means there would be one row. Hence, we wrote as d dot shape of 0. It would give us the answer as 4. Now we get d dot shape as 4, so it would run 4 times. It means we are giving inputs corresponding to 4 outputs. So it would run all those outputs one by one and then record weight biases and optimize it accordingly. So I will run this program. As you can see, now when I run this comes -1, 1, 0. Now what are these? So as Purushottam explained, weights and biases. Now flowchart you all have seen, giving 2 inputs, passing it through an activation function, and then giving the output. We have weight for first input, weight for second input, and bias for which is given in the activation function. So here we get -1 as weight 1, 1 as weight 2, and 0 as bias. Is this clear to everybody?
Yes, Bhaiya.
Yeah. So for those who are not using Jupyter, this is coming Jupyter notebook. In the output would be shown like here below the cell. Now for those who are not using Jupyter notebook, I've written as a form of normal Python IDE. Here I have used PyCharm to write it. It would similarly in other IDEs like Spider. Now, if I run this, as you can see here, I got the output as -1, 1, and 0. Same code, and the output is also same. Weight 1 is -1, weight 2 is 1, and bias is 0. Here we have all our values stored. See, this is the thing, and if we see it as an array, so this is an array 0, 0, 0, 1, 1, 0, 1, 1. This is the output. See, 1, 0, 0. The 0th order, this is of 0, so 0, 0, 1, 2, 3 are the indices. So for 0, 0, it is 1. It means 0. If we give 0, 0 and 0, 1 as input, 0, 0, the output should come as. Okay. I hope this is all clear to you. See, this multi-perceptron. Here I have fitted more layers of perceptron. I will not be explaining this to you because this is easily explainable. I have also added some comments through which you can understand this. I will just post it in the chat bar after the session. Now I will move to CNN. Let me expand it. Now, CNN is a multi-layer model in which we give many layers. Each input is given to different units, as you might have shown in the, as you might have seen in the PPT. Purushottam, can you show your PPT? Purushottam?
Yeah,
Hello?
just a second.
Yeah, the CNN,
Just a second.
the flowchart.
This is it. This one, right? This one, right, Shankar?
The flowchart in which input was given, not one. Leave it, I will search it now. Yeah, is my screen visible again?
Yeah, it's visible.
Yeah. So here, as you can see, this is a typical model of a CNN. Now, CNN is basically used for using perceptron, a single layer perceptron and adrenaline. These are the basic neural networks through which we easily train our 1D models. But in real life, the application needs is 3D, 4D, and even 6D applications. Suppose a very basic example of image classification. What image is? Image is just a 3-channel array. It means it has 3 matrices. For every it 3 matrices, as in one matrix for R, another matrix for green, another matrix for blue. As you must know, the color have its property as RGB, red, green, blue. Suppose we take at the pixel 80, 180. See, suppose this is the point of pixel. Now, if we take the value, so what there would be in the image matrix is at R value, what is at that position. And the green matrix, it would be what is the green component of that position, and what would be the blue component of position would be in the third matrix. So let me show you RGB example. My net speed is not that good. Please me. See, while it is loading, let me take anything else. See, when we put an image through a convolution network, like here, we have multiple layers which are hidden in it, and then a final layer. So for each layer, we need to integrate it with its previous and its next layer. So for that, we use different functions. For integrating it to its previous layer, we use convolution, and integrating it to its next layer, we use padding. Now, what is the difference between convolution and padding? Conventionally, not a rule, but it is a convention that the next layer is always has either equal or more number of hidden layers with its preceding layers. Now, with more layers, I mean more features to break into it. Now, what happens in a convolution neural network is we give our initial input. Suppose we give an image as an initial input. It would break into multiple pieces pixel wise. Then it would pass through first layer, and suppose n layers are there, so it would keep on breaking depending on the next layer and then keep passing. Now, what we think by our instinct that more number of layers provide us with more accuracy. Well, this is a very common mistake which people make. In convolution neural network, it is true when you add more layers, you get more accuracy. But after a certain point, breaking that image is not possible because that image also has its certain resolution. Now, if we break that image into the pixels start splitting. Initially, suppose the image is of 1000 by 1000 resolution, and we first break it into 5 parts. So we get more 5 matrices of 2000 by 1000 resolution pictures. Then again we break it into more parts, say 10 parts. Then those each matrices would again be break in 20 by 20 matrices. Now suppose if you give 20, break those into 20, then it would be split by pixel by 1 pixel. Now this is the maximum limit through which you can split your image. After this, the pixel value will start getting splitted and you will get noise in your input, and as well as it would reduce the efficiency. Suppose after splitting it into 20 more parts, we give another layer of say 20 more. Now that 1 pixel would have to break into 20. So what our programming language does is, it instead of to one it gives one, to other it gives zeros, or depending on different programming language and interpreters and compilers, it even break into arbitrary functions which have to make one. This would give us noise and decrease the accuracy phenomenally. Yeah, see it. Suppose I want basic color like black, 255 is the maximum limit for RGB and 0 is the minimum. So if you give all colors at 255, it means all colors are at their full intensity. You know, white light is made of all colors, it would give us white. Now if we give 0 to all, it means there's color, hence it would give us black. Now if you start in, it would start going towards red. It is getting maroon. It is a mixture of black and red. Now I'm setting it again as 255. Now if you start decreasing a certain color, let's say blue, to 40 I give, it is a shade that is of blue but has more intensity of the mixture of red and green. This is how an RGB value works. Is this all clear? Any doubt? Hello?
No
Hello?
doubt.
Okay. Now, one second, I will post these codes in the chat box. You just fix it in your ID because we don't have that much time that we can go as along writing the codes.
Sanskar, I got some pics for it, where RGB and matrices are there. So I would like to share and explain. If you want to explain, you can explain with that also.
Pardon?
I got that RGB matrices editing thing. Convolution operation of m cross n cross 3 images of 3 cross 3 kernels. So that would be better if
Can you just post? Can you
actually
just post in the chat? It is breaking for me. My net connection is not that good today because of some problem here.
it's a video, so posting it won't won't work.
Please wait for a second. I have posted all the codes in the chat box. Just put in your ID. I will be back in a jiffy.
So guys, is anyone having doubt or something? Yeah. So guys, what Sanskar was uh, telling, it's there. I can share and explain you guys.
See, for imagification and video optimizing, the knowledge of RGB values and color should be clear. So Purushottam would be telling you a bit about those.
Yeah.
So after he completes, we'll proceed with the CX.
Okay. So guys, you can see this matrix, right? You can see this matrix. So the kernels would be there. The channels would be there. Hello. Am I audible? Guys, am I audible?
Yes, you're audible.
Yeah, yeah, you're on.
Okay, fine. Yeah. So as in the screen, you can see these are the input channels, the red, green, and blue. The three values are there. And we are having different channels, 1 2 3, these three different channels. We are having 3 cross 3 matrices we are taking at a time, and then multiplying it with the kernels, getting the values and storing it in the outputs. That word CF value, that in the PPT I showed you, right? This thing, this is CX. This is what it's doing. Yeah, this is what it's doing. Red, green, and blue. All the three values are being extracted using the kernels, the output values stored. That's what I wanted to say. Yeah. Sanskar, you can continue with that. I think they would be much clear with this. I think. Guys, are you clear with this? Guys?
Guys, please respond. You get to know that you are clear with something, or we have to explain a little bit.
Yeah,
And
that's what.
urge you. speak up. This is for your benefit. You should speak up that you understood or not.
Yeah. Sure, you were saying something. You're not audible, sure. You can use the chat box if you want.
I was saying understood.
Okay, fine. Cool. Sanskar, you can proceed.
Okay. Is my screen visible to you now? See if no one is speaking, I'm invisible.
Yes, it's visible.
Yes, it is visible.
See, suppose we give an image into this convolutional network, and is of it has 60. It breaks into 64 parts. Now this will each have a different model. Suppose 1, 2, 64 models. Each of these 64 models will have weights and biases. It would cells for different weights and biases. Then it would further pull to another layer, let's say 128. I'm sorry for tardy work, but I'm using a mouse to do all this. So here it would be 128, and just output from here. Okay, what will happen is this would be a matrix of let's say it is a 4x4 matrix. Three. Let's say it is a 3x3 matrix. So 3x3 matrix means each picture will have a RGB value. It's 3 frames. So it would go into the first layer. It would get split into 64 parts. Each part would get trained on a specific model. Then it would further pass on to another layer. Now this is a simplified model. What happens is we are just taking so input comes as 3 matrix. This is layer 1. The inside ones till 64. See, it is exactly 64. It inside is a grid. An input comes to all of these. Then the next 128. So this input goes to all. This was each model of previous gives input to each model of the next layer. This is what we do by pooling. So see, I have posted the code previously. All of you have pasted in your ID, I hope. Now with the code. See, for here, I know you all not data set, so I have used an inbuilt data called CIFAR 10. It has 10 different classes. See, CIFAR 10 is an inbuilt dataset. It has 10 different classes. The more elaborate version of it, CIFAR 100, it has 100 dataset, 100 classes. So in CIFAR 10, we have airplane, automobile, cat, deer, dog, frog, ship, and truck. So image would become for training part, image of let's suppose an auto is coming, it would get trained, and weights would get trained, and the output target would be automobile. Similarly, all would get trained. Then in these biases and weights would be saved. Now for testing stage, we will take an image. We do not know what it is. It would get splitted with its all matrices, and then it would go through all this process. It would be multiplied by weights, the bias would be added, and the final we will get a value. Now that value would be compared with the different values which we got initially using the step functions, which I explained earlier, and then we get a certain class number for that, and then the result would be shown. This is how a basic image classification model works. Now, for testing purposes, for learning purposes, we are using only classes. I have taken 3 classes, index is 0, 1, and 2. 0 is airplane, 1 is automobile, 2 is bird. 2 classes. Now, what is concatenation? Here we took 3 individual classes. Now we need them as a single matrix so that it can be trained. We are taking 3 inputs, 3 outputs, so it would be a 3 cross 3 matrix. By concatenating it, we would be adding row by row or column by column, depending on how Y is there. Suppose we have a matrix 1 cross 4 matrix, and we have 4 such matrices, and we concatenate these 4 matrices. What will happen is each row would get appended, and it would become a 4 cross 4 matrix. Now, first of all, run this one. If you have all the libraries installed, it would get run. A Java notebook, it would come 8, and if you are using another IDE, then you would just run entire program itself. You can just run it. It would take some time. In second cell, it would again come. Again, a cell number would get changed to 9 here. Now the next is loading the dataset sets. Run this. See, it is getting downloaded. Now the net speed is ridiculously slow, so it is showing this much time, and after give an error because of net speed. Yeah, see, as you can, connection reset error because my connection is not good. So in your PCs, I hope it would have and would have started downloading. If it gets downloaded, please tell me so that I can proceed further. Has everybody downloaded it? Hello? Audible? Hello? Okay,
Yes.
I'm assuming that you all have loaded, so I'm moving forward. Now we have loaded our CIFAR 10 data in X-train, Y-train, and X-trace Y-trace. Now what this X-train, Y-train, and X-trace Y-trace is, see, we get the dataset in these preloaded. These preloaded datasets are of different types. Now what most type is, we get the training value for X. X means the what type of picture, and then the training value of Y is those indices. Similarly, we get them, so we get a test value and for X and both. Now what we do is, as I have shown you before, we have defined a function over here which would take only 3 classes because we're testing it, so we need it to run fast. So we take just 3 classes to train it. Now X-train, Y-train, we are overwriting these values with the 3 classes which we have just chosen. Similarly, get modified for test values, and then see, I have got an error, but if you do not get an error, it would print the dimension of X-train and extraction Y test. If anybody has run it, please tell me so that you can share the screen. Has anybody done it? Please say yes or no. Hello. Okay. If nobody is interested, then let's just move forward. See, if you would get some shape depending on the size of the data, which I do not remember. Now, next, if you want to see what images are like, you just take any better image. I have taken 3. You can take any. Now, previously my data was good, so I preloaded all these. So this is showing what I have done previously. Now, as you can see here, X train 3, it is an array, and array is like 255, 255, 255, 255, all 255. You know what does it mean? It means there would be a white color at that pixel. Now, this is an entire array.
Sanskar,
This
there is,
dot dot dot.
excuse me, Sanskar, there is some error. I think someone is, the code is not given complete. So can you please check it?
Where is it showing? Yes, I ran this code and it ran before. I have the out with me.
Check the chat box.
Okay, so given code is not complete. Can we share an entire file using this? If I would just share this for Jupyter Notebook, you can run it. Wait a second, I would just make it in a one single file and then send it to you. See now, see, must have gotten full code. Is there a does it know that is there a limit in chat box for number of characters? I guess there is because it is not showing further that analysis. I will share Google Drive link for that. I'm doing the presentation now.
Sanskar, I think we should share the link afterwards because it's almost the time. So
Yeah,
just
I'm uploading that in Google Drive and then sharing that link.
okay. So just explain them. Then we'll be sharing the recordings, so they will be able to know what it is like, how they have to proceed.
Yeah, 1 minute. You guys just try using that Google link in the chat box. I hope they're done. Okay, now I'm starting the session again. Is my ID screen visible? Hello.
Yes.
Okay. So here, if you write x3, it would take the third value. It means third index, which means fourth value of the x-train matrix array. So it would. This entirely is just third value, and dot means there's further more to it, but it doesn't have enough space to show it. So here, as you can see, it might be the boundaries of that picture. So it is showing 250, it means white. Now here, as you can see, there are different values because the color has changed. Now these three class names which we took for training them, as we took these three values, so it is aeroplane, car, and bird. Now, if you want to see what these images are and what these look like, we can just some random examples and then showing it. This entire code here, that till from plt.figure to plt.show, is for displaying that image from this matrix value. So as you can see, so we take this image for car here. The values which we saw, the white, it not these areas. These where my cursor is. For different values, suppose it would be just here value. For this value, we will get just one pixel over here. We will get a 3x3 matrix. For different pixel, we will get different matrices. Now, till now, what we are doing was importing the data, making it short so that we train it in less time, and then now what we will do is fit them in the convolution neural network model. First of all, we need to import some functions from Keras libraries. So I hope you all must have installed Keras. I told you in this beginning of the session. What we are doing is we are taking 2D convolution model. So is what do you mean by 2D convolution model? See, suppose we are training a model. We all know that images are of two types, at 2D and 3D. So these images are all 2D. We can take convolution 3D model and put it. What would happen? It would take a dimension, means the third channel of matrix to be 0. This matrix to be the value which we have given. It just increase the training time, the computation power used, but give the same result. So we know that we have 2D pictures. So we will just import convolution 2D, max pooling 2D, patch normalization, dropout, flatten, input, dense. These all are imported from Keras library. Moving forward, first of all, we create our model. Now, whatever neural network we we always create a model. What a model is, as I have shown you in the board, that and it gets split into different neural network units, and then it is trained. So entire grid of training is model. First of all, we create our model. So we are making a function named create model. First of all, we add a convolution box. We have a clean slate. We nothing have on it. So start out by creating a convolution block. We create a convolution box. For that also, first of all, we create a function convolution block, and the parameters which you get is model and number of filters. So to create a model add. Now what this model is, this model was previously imported from the libraries. Hence it will as a model.add convolution 2D. Now number of filters, 3, activation, padding. Now what number is, let me show you at the end. Till here we have created a model. Now create. Now we are giving that function model equals to create model and model dot summary. This is the initial data we have given. We will put into this model and then run it. Now model dot activation function relu. As Purushottam explained many activation functions, here we rectifying linear relu function because it gives the best result. Now we are adding two layers, so we are using two activation functions over here. Then we add another activation function. This is the final layer, the final output layer. Here also we add an activation function. Here three activation functions are used the most: softmax, sigmoid, step, not step, binary sigmoid. And the difference is when we have multiple classes, we mostly use softmax, but for single classes we use binary or sigmoid. Now we are here creating a model model.tf.keras.model.seq. Here it would create a template for a model. We'll add the model with its shape. Now what the shape is 32. We know that the image set which we gave, the CIFAR 10, has a shape of 32 pixels by 32 pixels. Sorry, 32 pixels by 32 pixels, and it has three different color components. It is RGB. So we are given. Now we add convolution blocks. Here we define what convolution block is. A convolution, it would just keep on adding number of layers. So model and number of layers is 32. Number of filters means when we are giving a matrix split into different number of values, and it would keep on adding and adding to it until the value which we have given. So suppose we have given 32, so it would create 32 different units, which would be optimizing our weights and bias. Then it would go to second layer, which is 64 units. It would get then another layer with 120 units, and it optimized again. Now model.add flatten. What we do here in flatten is, see, when we have created so many units, so the input image which we have given is now split into different units. Suppose which we gave a normal image whose length is 2 pixels by 2 pixels, hence it would have 4 matrices. Each 4 matrices would further have 3 more channels. So these matrices would get split into some other different values. Suppose we take the first matrix. First matrix all has 255, 255, 255, 255. It would get sampled into a smaller matrix which would be given to different units. Now we have a scattered image. We have to compile it into our original image in order to get a better result from the final activation function which we use softmax over. So we use the flatten command. Using the flatten command, it gets back compiled to our original type of image. Then we compile the. Increase this. See over here we are add dot dense 3 activation softmax. What we are specifying by 3 is that a scattered image was earlier at 3 channels. So flatten would be flattening it, but we add dense for the final layer which would give our result. For that we give 3 channels, so it would give a better result. If you give a wrong channel, it might give error or would not give a better result depending on the type of model you are using. Now by compiling it, we have some more parameters that we can optimize. First is loss, but means how would you decrease the loss? As you have learned in backpropagation, there's an error which we give as a feedback. So we do not give the output minus input. We do not give it to the feedback like this. We optimize it. In backpropagation, we use mean square error and then give it back to the input, and then it is processed. In convolution neural network, there are many types. One of it is categorical cross entropy. For multiple, we use categorical cross entropy. For 2 classes, we use binary cross entropy. Now, optimizers add. There are different optimizers. This is a very vast topic. You can just go to Google, type optimizers in CNN model, and you will get entire information about it. Then metrics. Here we specify what do we want as an output. Okay, then we run this model. See, till here, from the starting till here, we were defining what we will do in create model. Now here we run that function. Model is create model. So we make another variable named model and this show the model which we have created in it, and then model.summary would print the model. I have not run the previous command. My data set is not there. I don't think it would run. Let me test. Yeah, it would not run because data has not been loaded yet. See, this is the CNN. Does anybody have any doubts? Hello? Is this clear to everybody?
I think it's clear to everyone. So with this, I think we should wind up, right?